In this video, let's talk about smart queues. In UniFi Network Controller, if you go to your internet port setting, go to the advanced part, switch on menu, then you can see this smart queue setting. By default, it's disabled. Move your mouse here, you can see the short description. Even after reading this, you may still be confused what it exactly does and what exact problems it will resolve. In this video, we are going to dig deeper and go to the system to see internally how the feature is implemented technically and how it works. I have 4 UniFi routers, the oldest USG Pro, the relatively new UDM Pro and the USG Pro, and the most recent UDR. I'm showing you the smart queue configurations for each router. As you can see from the face, they look exactly the same. But under the hood, there are some differences. We are going to talk about that in this video. As you may know, smart queue management is very CPU intensive. It may significantly harm your network performance if your router is not powerful enough. But whether it's the case for UniFi routers, whether even for the most powerful UDM Pro and USG Pro, there's still that performance impact concern. We are going to talk about that in the second video to focus on performance testing. So in this video, we are only going to focus on technically how it works. Let's say you use a UniFi Dream router and you use a cable modem, and your cable modem is connected to your ISP, then connect to internet. That's a typical home network or small business network configuration, right? Let's say now you already have a computer which is uploading huge files such as a video to the internet. So there are a lot of packets are being sent through the router to the internet. In the network devices, there are buffers to buffer the packets which the system cannot send for now. So it will be queued up until it has capacity, then they will be sent out, right? If at the same time you have other internet applications, let's say you are having Zoom meeting or Skype calls, or you are playing some internet games, those type of applications, they may not use a lot of internet bandwidth, but they require very fast response time. And because there are a lot of red block packets from the uploading application which are already queued up, by default, those queues are first in, first out. So your new packets have to be queued up in the end of the queue. And to make the issue even worse, your modem has its own buffers. Your ISP has its own buffers. They will also be queued up differently. Your game application or your Zoom meeting will get significantly delayed. There's a name for this. It's called Bufferbloat. Basically, the root cause is the buffers are not properly managed in different network devices, so they don't work well with each other. They buffer too much, then they delay your time critical packets. To resolve it, technically, it's not difficult at all. You just need to properly maintain the queue in your router. Problem is resolved, but in real world, it's not that easy. You have buffers in your SP and in your modem as well. In most cases, it's impossible to control their buffers. To mitigate buffer bloat, the best way is to implement smart queue management. Many people may think about QoS. They may think, okay, as long as you give your VoIP application or gaming application higher priority, problem is resolved, right? Smart queue management is a little bit related to QoS, but it's not exactly the same. For the traditional QoS, the system will check the port number and the special flags in your packets to determine what priority should be put on those packets. But in modern internet applications, more and more applications are using, let's say, VPN or HTTPS. It will be difficult for the system to know what's the nature of each packet. The other problem is the traditional QoS needs very diligent day-to-day management, monitoring, and improvement. For small business or home users, it's not realistic. For home users, there's one thing which makes the situation even worse. Most home users have different download and upload speed, and the upload speed normally is much slower. Nowadays, people have more and more needs to upload stuff. Let's say upload video or backup photos. So the issue is becoming more and more critical for many users. The smart queue management is UniFi's way to mitigate Bufferbloat issue. On the screen, I show you 4 different terminal windows. I'm going to use them to log on to the 4 different UniFi routers. For the 4 routers, USG Pro uses the old Edge router OS, which is replaced by UniFi console OS. The USG Pro is special. The internal settings are also a little bit different. And for UDR, it has weaker hardware. UDM Pro and USG Pro, basically the hardware are almost identical. So let's see whether the hardware difference has any impact on the implementation. First, take a look at USG Pro. I already SSH into the USG Pro, and in the left, just for comparison, also show the UniFi network controller for the smart queues setting. As you can see, I already enabled the smart queues. In USG Pro, it has many CLI commands which are missing in the newer OS. Let me show traffic control. This part of JSON will be corresponding to the UI here. It doesn't reflect too much new information. It says download 300. We have the same information here. Upload 20 megabits. Yes, the same information. The only new thing it tells us is about ECN. Later we will discuss the ECN. Let me exit the configure mode. In later part of the video, we are going to use the Linux command tc to check the settings. But if I run tc here, not available. Apparently for the old router OS, it's using different approach to implement traffic control. It's not the same as the newer OS. That's it for USG Pro. I won't show it in the later part of this video. I'm going to focus on the newer OS, which has more details to discuss. Let me SSH into the other 3 UniFi routers. Okay, I'm in. I need to show you Linux command menus to explain some basic concepts about traffic control. Unfortunately, in UniFi's operating system, it doesn't come with man command. So that's why in the upper right window, I'm showing you a random Linux machine. And here I can run man command. The command I want to show you is tc. Let's see how UniFi use tc to implement the smart queues. UniFi router's new operating system is based on Linux. tc is short for traffic control. It is used in Linux kernel to configure traffic control. As you can see, it has many functionalities. In fact, the smart queues in UniFi network router only use a small subset of the functionality of tc. The most important concept to understand in tc is queue discipline. When kernel needs to send a packet to an interface, is enqueued to the queue discipline. Your packet is enqueued to queue discipline only when the kernel sends a packet. Think about from your internet usage perspective. Send means upload. Then you may ask, what about download? We will discuss that later. Let's first check before and after we enable smart queues in UniFi routers. What's the queue discipline changes in the system? As you can see, I already disabled smart queues in the 3 UniFi routers. Let's go to the SSH sessions again. I already input the command for each router. As you can see, they are pretty similar. It's just TC command, and then I want to display the queuing disciplines, and I say show, and then followed by the device, which is my WAN part. So for the UDR, it's S4. For UDM Pro, it's S9, which is the 10 gigabits part, and for USG Pro, it's S2. It's also the 10 gigabits part. Let me execute them. It's the first surprise already. See the queuing discipline is no queue. We will talk about the no queue thing later. For UDM Pro, this makes more sense. There are 5 queuing disciplines. The root one is a multi-queue followed by 4 first in, first out fast queues. Again, we will discuss the settings in more details later. For USG Pro, exactly the same as in UDM Pro. Let me enable smart queues for all the 3 routers, then go back to SSH. Now let me run the same command again after enabling smart queues. For UDR, as you can see, it's changed. Now the new queuing disciplines make sense. The root is a HTTP. We will discuss that later. And then followed by fair queue codel. For UDM Pro, the same queue disciplines for USG Pro. Yep, same case, the same settings. Because for UDM and USG Pro, they are exactly the same before and after enabling smart queues. In the later part of this video, I won't talk about USG again. We will focus on the UDM Pro. For UDR, as you can see, before enabling smart queues is completely different. After enabling, the parameters are a little bit different. Let's go back and focus on UDR and UDM Pro. I already set the smart queues configuration back to disabled. Now let's revisit the UDR. Default queuing discipline is no queue. I have a hard time to find the official document for the no queue discipline. This is the only thing I can find on internet. So when you set it to no queue, when a packet is sent through the device, if the device has capacity, it will send it. Otherwise, it will be dropped. It sounds pretty brutal. That implies UDR will have a lot of package dropping issues when the device is very busy. Let's move on to UDM Pro. Rerun the same command. So the root queuing discipline is MQ, which is multi-queue. Let's check the man page. Scroll down. In the queue disks section, you should be able to find the multi-queue. Yes, here. It's optimized for device with multiple TX queues. I assume Ubiquiti use multi-queue here because its CPU has multi-cores. For example, the UDM Pro has 4 cores. Under the root, it has 4 FIFO fast queue disciplines. You can find the definition in the same man page. Let's scroll down. Yes, it's here. So it's standard queue disk. The important information is it honors type of service flag. On the screen in the upper right window, I show you the man page for FIFO fast, and in the lower part I show you 2 documents from the Linux traffic control how-to documents. The left one, there's a graph explaining how the 3 bands work, and in the right side it explains the type of service flags and the priority map. If you look at the UDM Pro's results for the TC QDisk command, you can see the 4 first in, first out fast QDisk. They all have 3 bands and they all have the exact same priority map. So if you read the document, you can see during runtime, the system will read the type of service flag from your IP packet header, it will use this hard-coded mapping to determine which band it need to put your packet to based on your TOS type of service flags. Pretty simple mapping. A packet comes, simply read the TOS, decide the band, and then put to the band. That's it. And there's a fine note here. You can see packet always dequeued from band 0 first, and then band 1. Then to make any further discussions, we need to understand several very important terms in Linux traffic control. First one, queue. So basically, queue is just another name of buffer. It contains a finite number of items waiting for an action. So the finite number is keyword. Later you can see in the UniFi smart controls, based on your indicated download or upload speed, the system will define different memory sizes for the queues. Next concept, flow. It contains the source IP, source port, destination IP, destination port, direction. It's just to define a distinct connection. It contains a set of packets. Later, you will see to support smart queues, UniFi uses one of the queuing discipline, which is called HTB. To understand it better, you need to know what's token and what's bucket. We don't have enough time in this video to talk about all the details. If you are interested, you can go to the Linux traffic control how-to document and take a look at all the details. Okay, now let's go back to our main page. For traffic control, there are three very important things. We already briefly talked about queue disciplines, right? Now let's move on to class. So some queue disk can contain classes. Let's look into the system to see what are the classes UniFi uses when we haven't enabled the smart queues yet. I typed in the new command in the UDR SSH session. You can see it's very similar to the queuing discipline command. The only difference is I replace queueDisk with class. So let's see what's the output for UDR. Nothing. It makes sense because the queue discipline is no queue. It doesn't really need any class. Move on to UDM Pro. It has 4 MQ class, and each one has its own ID, and each one is a root. Under the root queuing discipline, there can be multiple classes. Each class can be associated with its own queuing discipline. It's a tree structure. Here, let me show you the class structure I prepared for UDM Pro. Blue color represent queuing disciplines. Green ones represent classes. In the left side, you can see the root queuing discipline is a MQ. The ID is 0 : the ID has two parts. The left part is called major. The right part is called minor. And there are very detailed definitions how to interpret the numbers. We won't cover those details. For the root, it's 0 : Under it, from the class command, we know each MQ class has its own ID, :1, :2, :3, :4, and they are all roots. Go back to the queuing discipline command. As you can see, for the 4 first in, first out queuing disciplines, they have their parents. Their parents are the 4 classes. That's how we interpret these two commands outputs into this class structure. As mentioned earlier, the reason under the root queuing disciplines you need the leaf queuing disciplines or classes because you may want to classify or categorize your packets into different classes so that you can have different priorities or different ways to process them. But for this smart queue disabled mode, it's very simple. It's just because the hardware, it has 4 CPU cores, so that's why it has 4 first in, first out queuing disciplines, and in the root, it has a multi-queue. So pretty straightforward. We'll finish the smart queue disabled mode. Let's move on to the real interesting part, which is what if I enable smart queues in UniFi routers? In UniFi controllers, I have set the smart queues to enabled, and I specified the same down rate and up rates. For now, you can ignore these two settings. We will discuss the reason we need to specify the rates and what rates you need to use later in more details. For now, let's simply enable them and make them have the same settings. Now let's go back to SSH. Let me run the same queuing disciplines command in UDR. It's changed dramatically. Before enabling the smart queues, it simply doesn't have queues. Now it has 3 queuing disciplines. We will discuss all of them in much detailed fashion later. Let's temporarily move on to UDM Pro. Let me run the queuing discipline command here. If you compare the two outputs, you can see they are almost identical. In the remaining part of the video, I'm going to focus on the UDM Pro. Let's examine the output. The very first line is for the root discipline. The name is HTB. This is one of the most important queuing disciplines used by smart queues. Go to a Linux, type in this man command. In the description, you can see it allows you to use one physical link, which is one part in our case, to simulate several slower links and to send different kinds of traffic on different simulated links. Now you may already get the idea why smart queues can resolve the Bufferbloat issues. Just by using one physical one part, it can let your different applications use their own simulated slower links. That's why each one can have fair share of the bandwidth. Just from the name, you can see it's hierarchy and it's using token and it's using bucket. The terms we mentioned briefly earlier, so you can do your own research if you want to dig deeper. The next queuing discipline is called FQ Caudal. This is the second important queuing discipline used by UniFi in smart queues. You can go to TC FQ Caudal to get more detailed information. FQ means fair queuing. Caudal means controlled delay. Fair queuing with controlled delay. It classifies incoming packets into different flows and is used to provide a fair share of the bandwidth to all the flows using the queue. Let's take a look at the third queuing discipline. It's Ingress. This is a little bit confusing. If you go to the main page for TC, you can have a brief description about the Ingress queuing disk. It applies to incoming traffic on an interface, allowing it to be filtered and policed. Why for incoming traffic it needs a dedicated queuing discipline? Let's check the concept of egress and ingress. Let me use this simplified diagram to explain egress and ingress. So let's say you have your home network and you connect through the one part of your UniFi router to internet. So the traffic which is outgoing to internet is egress, and think about internet usage way, it's upload. Everything which comes into your home from internet is ingress. It's incoming and it can be considered as download. These two directions are super important when it comes to how UniFi router deal with the smart queues. Linux traffic control works on egress direction, the outgoing direction. So you may wonder then how smart queues deal with the download traffic, which is ingress or incoming. Now it's time for us to look at the third most important objects in traffic control, filter. I show you the Linux main page. It explains what's filter. Whenever traffic arrives at a class, it needs to be classified. Then your filter attached to the class will be called until one of the filters returns with a verdict. I'm going to run this command to see the filter for the ingress queuing disk. This command is a little bit tricky. If you only say show del S9, it won't display anything. Just like one part, it doesn't have any filter, but it's not true. Remember in the main page about filters, it mentioned a filter is attached to a class, and because your interface may have a hierarchy of queuing disciplines and classes, when you want to display the filter, you need to indicate for the root or for what parent. For ingress, it has this name, so I specify parent with this ID. Let's run it. I won't explain all the details. What it says is apply the filter to everything. As long as it's ingress, it will take just one action. The action is called MIRRED, means mirror or redirect. In our case, it's egress redirect to device IFB0, and here it says stolen because mirror is copy, redirect is steal. So basically, the new device here, IFB0, will steal the ingress packet from S9 device. So then let's see what this magical IFB0 is. Apparently, it's not our physical parts in the UniFi router. In this Linux Foundation wiki page, it explains what's IFB. It stands for Intermediate Foundation Block Device, and it's used in traffic controlling to replace the previous IMQ IP tables module. Now we have a new device, which is IFB0. We need to continue run similar command, but this time against this part. Let's see what's the queuing disciplines for it. Very similar to what we have in the upload case for the one part. Now we are clear about how the system deal with the incoming and outgoing traffics differently. Let's move on to the next interesting topic about the down rate and up rate, which you need to specify when you configure smart queues in your UniFi router. Remember in the beginning of the video, I show you this example diagram to explain the Bufferbloat issues. I mentioned outside of your control, you have the modem and SP. They may both have their buffers, but their sizes or how they control their buffers are out of your control. No matter what you set in your routers, it can only resolve the problems within your home network, but you cannot influence their buffers. The way to address that is when you set the smart queues, you need to give the down rate and up rate. You want to give the rates which are slightly slower than your real internet upload and download rate. You may start with something like 80% or 85% of your real speed and go from there, pick the ones which fit you the best. As you can see, when you enable smart queues, you need to specify these two parameters. After you set that, because your rates are slower than your real internet's rate, that means your router will make sure your egress traffic will not exceed the capacity. So your modem's buffers will not be used at all. And when it comes to download, you cannot prevent the devices in internet side from sending you packets. You simply cannot do that. But you can maintain your buffer in your IFB0 device so that when the rate is too much, is exceeding your specified rate, it will drop the packet. And then your internet side devices will learn the lesson, they will slow down. That's one of the reasons why so many people are confused, because they will complain why after enabling smart queues, my internet throughput is becoming slower. Of course, it will. That's by design. Nowadays, internet speed is becoming faster and faster, but in many cases, people's feeling about whether internet is fast fast or slow is not really determined by your absolute speed. It's determined by the latency. As long as you have the latency under control, many applications will run smoothly, even if they are running in maybe slower overall speed. Okay, having explained theoretically how the two rates work, let's go to the system to see how technically these two rates are in effect. Before we enable smart queues, I show you a class structure for the queue disciplines and classes, right? So now let's do the similar thing. I already run two commands against the Ethernet 9 ports, and let's draw a similar class diagram. You can see the root is HTTP1 colon showing here. In the class section, the root class is HTTP1 colon 10 and HTTP1 colon 1. So I show them here. Go back to queuing discipline. The first fair queue codel has ID 10 colon. I show you here. And then go to the class section. We have 4 corresponding classes. So this is the tree structure for the Ethernet 9 part. If you look into the details for the class section, you can see the 20 megabit thing. That's exactly what we said here in the upload rate section. That's how UniFi router will use your up rate. It will specify the classes for your WAN part. Then you may wonder, where is my down rate? Remember, it only deals with the egress traffic. We need to look into IFB0 device for the download. Let's do it now. For IFB0 device, I run these two commands and accordingly I draw these class structures. I won't waste your time explaining the details anymore, but there are two things I want to mention. First, remember for down rate, we specify 300 megabits, right? Okay, it is showing here. It is used to limit the rate for the IFB0 device. And another thing is, see here, it's showing multiple classes for FairQ codel. Basically, it has the similar situation for the one part. So as leaves, you may see one or multiple FQ codel classes. They come and go. During runtime, based on your current traffic situation, the system will add or remove FQ codel classes on the fly. So that's why if you run the commands at different time, you may see different output for the class section. Next, let's move on to another interesting part, because so far I have been using the same 320 example settings, right? So you may ask, what if we use different rate? Will they impact anything in the system setting? Let's validate it. In the UniFi controller, I'm going to change the down rate and up rate, and then in the left side I will run the command to show the configurations for queuing disciplines and classes. Let's see the different down rate and up rates, how they will impact the detailed parameters. First, let me start with my physical max speed, which is 10 gigabit. Okay, you already see the error. Down rate must be at most 1000 megabits. So it's the upper limit of smart queues in UniFi. Let me try the upper limit 1000. It's effective in the left side. Let me run the commands. It's the first one. Let's leave the output here and then go back. Change the settings to another set of rates, then let's compare them. Okay, I changed the speed to 300 megabits, and in the left side you already see the result. If you compare the queuing discipline part, they are exactly the same as the 1 gigabit speed situation, and for classes almost identical, except of course, the speed rate is different, and then the burst setting is slightly different. We won't have enough time to discuss all the details. If you are interested, you can do your own research. But basically, switching from 1 gigabit to 300, the settings are not changed too much. Before we move on to lower speed, there's an interesting thing. If you click the I button here, in the UniFi controller, you can see the last sentence, not recommended for connections faster than 300 megabits per second. So my understanding about the 300 thing is it won't improve too much. So maybe it's not worth it to implement smart queues if your internet speed is faster than 300 megabits. This time, let's test 10 as the down rate and up rate. In the left side, let's check the commands output. So for queuing disciplines, almost identical, but the limit is changed. It's smaller than previously. It will deal with less packets. It makes sense. And the quantum is also changed. We won't spend time to explain the details. That's the difference in the queuing disciplines. If you move on to classes, of course, the rate is changed. This time I reduced the speed limit to a very, very low value. So let's see whether it causes any strange setting in the system. If you check the queue discipline part, it's identical to the 10 megabits case. Nothing's changed except for just one part, the ECN thing. This is the Wikipedia page for ECN. It stands for Explicit Congestion Notification. It allows end-to-end notification of network congestion without dropping packets. Just by reading this, you may already understand why for very slow internet connection, it's not recommended to enable ECN. So that's why when we set the speed limit to very low, the ECN flag is gone. Thank you for watching this video till the end. I know it's a long video, but traffic control or just smart queues is really important topic. There are a lot of interesting details to cover. Thanks for watching.